Yan. So, let's go back here. So, what is a critical angle? So, a critical angle in a skywave propagation is the image result for the critical angle of refraction skywave propagation. So, meron siyang angle of incidence na tinatawag. So, pag critical angle, waves that enters at too steep of an angle pass through the layer. So, as the angle shallows, the refraction increases until an angle is reached where the wave is refracted back to the earth. We call this the critical angle. Hmm. So ito, hindi pala siya kita. Pero kung mapapansin nyo, sa wave, okay, pag hindi pa niya na-meet yung certain frequency, okay, kakaroon siya ng critical angle. So we call that yung pagbabounce niya or pag hindi niya pagbabounce, no, ibahin natin yung term. Okay, pag hindi niya pagre-refract back to the earth, yun yung critical angle. So balikan natin. So for critical angle, particular frequency and degree of ionization, it is possible to define the critical angle which total the refraction does not take place. So defining the critical angle also establish the minimum range or that skip distance any ray traveling away from the area at greater than the critical angle will be freely refracted down to about 5 degrees above the horizon. So, yung sa critical angle or sinasabi nating angle of incidence, pag yung wave that enter at too steep of an angle pass through the layer. So, too steep. Okay, so kung mapapansin natin dito, sorry, malabo. Ayan. Too steep, too steep, too steep. Yan. Sa critical angle, so it might not refracted back to the surface. I'm sorry. So, sinasabi din, no? Skywave propagation is used for the propagation ng electromagnetic waves, the frequency 3 to 30 megahertz. So, space wave propagation used for very high frequency range transmission above 40 megahertz. So, when we talk about the dead space, because of the high frequency used in skywave transmission, the ground wave travel is not as far as the returning skywave. So the distance between the limit of the ground wave and the first returning skywave is the dead space. So para maintindihan natin kung nasan yung dead space, ayan si ground, ito natin. Ayan. Okay, nandito si transmitter and receiver. Okay? So, sinasabi, di ba? The distance between the limit of the ground wave and the first returning sky wave is the dead space. So, merong limit lang si ground wave. So, which is a ground wave, itong side lang siya. Ground wave. And then sinasabi, the first returning sky wave is the dead space. So yan, nag-return na the first returning skywave is the dead space. So kung mapapansin nyo, itong part, yellow na lang. Yan. Itong part is dead space. Ayan. Yan si dead space. So the ionosphere. So when we talk about ionosphere, the ionosphere consists of series of conducting layers between the height of 50 to 400 kilometers. It exists because of the transmission of ultraviolet radiation from the sun. Kaya siya nagkakaroon ng conducting layers dahil meron siyang transmission from the ultraviolet radiation galing sa sun. So, intindihan natin, si Earth, may ultraviolet radiation na pumupunta galing kay sun. Okay, nagkakaroon ng conducting layers. Hindi kita. Okay, nagkakaroon ng conducting layers si Earth. Kaya nagkakaroon din ng pag-travel ng radio waves. So because of this dependence upon the radiation from the sun, the height and densities of layers vary according to the time of day and season of year. So to understand, the three main layers have identified, designated as D, E, and F. There is also a connection between the 11-year sunspot cycle. Short-term effect occurs in a random fashion, resulting the ionized layer being in a state of constant turbulence. So, sa may letter F, layer splits into two separate layer during the day. Yan. Merong two separate layers during the day. So, syempre, sa araw na yan is mataas yung ionization. Sa D naman, okay, kung mapapansin nyo, the D is region of low ionization that only persists during the day. Si E is more marked and remains weakly ionized but not ionized by night with a little change of height. So si E. When paggabi naman si E, okay, nagkakaroon lang siya ng change of height. Tumataas lang ng konti. So the F is the most strongly ionized and has the greatest diurnal change in height. So, itong absorption na to of radiation is also responsible for the ionosphere located within the thermosphere. So, the ionosphere is made electrically charged gas particle. So, the ionosphere extends from 37 to 190 miles or 60 to 300 kilometer. Kung nabanggit ko din kanina is from 400. Tama ba? Yeah. So, it ranges from that. So, it is divided into three regions of layer. Ulitin natin. F region, E layer, and D layer. During the daytime, the F layer split into two layers, then recombines at night. So, the E layer was discovered first in 1901 by Guglielmo Marconi, transmitted a signal between Europe and North America, showed that it had to be bounced off an electrically conducting layer about 62 miles or 100 kilometers altitude. In 1927, Sir Edward Appleton named that conducting layer the E or electrical layer. Additional conducting layer discovered later were simply called D layer and F layer. So since the ionosphere existence is due to the radiation from the sun striking the atmosphere, it changes in density from daytime to nighttime. So ulitin natin, no? So the ionosphere existence is due to radiation dahil yung from the sun, nag-strike siya sa may atmosphere. Kaya nagkakaroon siya ng change in density from daytime to nighttime. So, all three layers are denser during the daytime. At night, all layers decreases in density with the D layer undergoing the greatest change at night. So, sa D layer, essentially, nawawala siya. So, as seen around the 1900s, the ionosphere has the important quality of bouncing radio signals transmitted from Earth. Its existence is why places all over the world can reach the via radio. So, yeah, frequency and skip distance, by definition, at a fixed level of ionization, an increase in frequency will cause the ray, previously the critical ray, to become an escape ray. So, this causes an increase in skip distance. Ionization and skip distance at a fixed frequency of if ionization decrease, the effect is the same as above. So the critical ray became a escape ray. So this causes an increase in the skip distance. And then when we talk about the space wave, so the transmission at VHF and above cannot propagate by either surface or sky wave. So attenuation is severe that surface wave is virtually non-existent. These frequencies are too high to be refracted by the ionized layer aloft. So as a result, transmission is by straight line or direct wave, katulad ng sinabi natin kanina. In addition to the direct wave, a reflected wave can also exist. So the two components make up a space wave. Ganyan yung nangyayari kay space wave. So, yung kanina example natin, okay, the aircraft and to the receiver. Direct and reflected. Ayan yung nangyayari. So, because of the different emission path, the direct and reflected wave is sometimes in phase and sometimes out of phase. So, this produces lobes and nulls, particularly when the receiver is too close to the station. So, ulitin natin, nagkakaroon siya ng phase cancellation when the receiver is too close to the station. So, kung mapapansin nyo from the image, this one and this one, ayan yung kakaroon ng null. So, the phase cancellation is when two or more audio waves form clash with each other, resulting in deconstructive interference. So, ayun na, nandun na yung sagot. Two or more radio waves. Pag nag-clash sila, let's say, sending signal here and nag-send ng signal here, nagkatamaan, nagkakaroon ng nullification. Naka-cancel out yung audio wave. So the range of a space wave appears to be line of sight. In practice, it is termed a quasi-optical. So the lower atmosphere cause some refraction of the wave which bends it beyond the optical horizon. A further small increase is gained from the diffraction when the wave becomes tangential to the Earth's surface. Now we will talk about the frequency bands. So for the convenience, the radio frequency spectrum is divided into a number of bands, each spanning a decade of frequency. The use to which each frequency range is put depends upon the number of factors, paramount among which is the propagation characteristic within the band concerned. So, matagal ko nang sinabi to sa inyo na this is to be a uh, need to be memorized and recited. So, just freely read it again. The frequency and the designation. So, we'll give an example from 300 hertz to 3 kilohertz. The wavelength of this frequency range is from 1,000 kilometers to 100 kilometers. And the designation is extremely low frequency. Okay, when we talk about the wavelength is this. Yung wavelength. So when it comes to frequency range ng 3 gigahertz to 30 gigahertz, the wavelength is 10 cm to 1 cm. Okay, that is a super high frequency. So when you describe the wavelength of 3 gigahertz to 30 gigahertz, 10 centimeter to 1. Ayan. Ganyan yung frequency wavelength nila. In addition, syempre, various bands are set aside for radar use, and these are designated by letters. So kung mapapansin nyo, band designation LSCX, K, U, K, and KA. So the use of to which each band is put depends largely on how radio waves propagate within the bands in question and also on the working range and target resolution that can be achieved. So for example, band designation L is the frequency is 1 gigahertz to 2 gigahertz. The wavelength is 30 centimeters to 15 centimeters. In the aircraft radar application, this is used in distance measuring equipment. The X is 8 gigahertz to 12 gigahertz. The wavelength is 3.75 centimeters to 2.5 centimeters and typically used as a weather radar. So here are some examples of frequency allocations within the radio frequency spectrum. So other factors that need to be taken into account include the efficiency of practical aerial system in the range concerned and the bandwidth available. It is also worth noting that although it may appear from the figure that a great deal of radio frequency is not used, it should be stressed, sorry, that competition for frequency space is first and there is in fact a little vacant space. Frequency allocations are therefore ratified by international agreement and the various user services carefully safeguard their own area of spectrum. That's why nung una kong diniscuss sa inyo, there are designations uh, for different aspect when it comes to communication or nagkakaroon sila ng frequency allocation in other term. So, here are the examples of aircraft use and their frequency. So, from low to medium frequency, there is a non-directional beacon or NDB. Sa HF, okay, bandang 10 megahertz yung HF. Example of aircraft use is for high frequency communication bands. And then from VHF, yan, mas madami na dito. They're using 100 megahertz, band 2, FM radio. Examples nila ay instrument landing system, yan, VHF, omnidirectional range, VHF communication, and ACARS. And then between VHF and UHF, nandiyan si glide slope receiver. And then higher than that, 1 gigahertz and up, nandiyan na sina DME, global positioning system, satellite communication, microwave. Then the highest is the weather radar. Then to be more specific, the extremely low frequency or ELF, frequency starting from 3 hertz to 3 kilohertz is known extremely low frequency, which is hindi naman natin masyado na sinasama pero yan, 3 hertz to 3 kilohertz lang siya. This range is highly vulnerable to disturbance and easily gets distorted by atmospheric changes. It is hard to design a system in this range is challenging because the larger wavelength required long antennas which are practically impossible to achieve. So, yeah, mga scientists use this frequency band in seismic studies to understand natural activities in the Earth atmosphere. Okay, so extremely low frequencies are almost used in seismic studies. And then the very low frequency or VLF, starting from range of RF and practical radio transmission system, which spans from 3 kilohertz to 30 kilohertz. So the design and implementation of the antenna system are extremely complicated due to the wavelength. So it is used in submarine and still using in time radio station which synchronizes clock signals between two remote locations. And there is a low frequency. The low frequency in the range of 30 kilohertz to 300 hertz. One of the important properties of LF signals is that they will get reflected by Earth's ionosphere and thus it is suitable for long distance communication. So this long wavelength and less attenuation from big terrains like mountains, it's generally called ground waves. Itong mga low frequency na to are used by the amateur radio operators and it is one of the most important source of information transfer when another kind of communication source fail. Other areas for military applications like submarines, these are used. RFID tags in near field communication and low frequency radio broadcasting. From medium frequency, the most popular frequency band, a medium frequency operates in 300 kilohertz to 3 megahertz. They are widely used in AM radio transmission, navigation system for ships and aircraft, emergency distress signals, Coast Guard, and experimental application. VHF, which is the most commonly used by the aviation, from 30 megahertz to 300 megahertz. And other than aviation, these are for analog TV broadcasting, FM radio broadcasting, and from the air traffic controls and airline pilots from 118 to 137 to communicate with each other. It is usually affected by big terrains but is suitable for short distance communication. The ultra high frequency from 300 megahertz to 300 gigahertz. This is important for modern wireless communication system. Uh, it is used in GPS navigation system, satellites, pager, Wi-Fi, Bluetooth, television broadcasting, GSM, CDMA, LTE mobile transmission. And super high frequency from 3 gigahertz to 30 gigahertz. This system is extremely hard in the HSF band due to its smaller wavelength and complexity. And it is commonly used in point-to-point communication, satellite system, digital TV broadcasting, Wi-Fi, microwaves oven, and mobile networks. And here is the extremely high frequency. So the extremely high frequency band is the highest in the radio frequency from 30 gigahertz to 300 gigahertz. So EHF is only used in advanced communication, used in radio astronomy and remote sensing, weather analysis. So it is suggested to use a high-speed internet systems like 5G technology for future transmission networks due to large bandwidth availability. Well, that's are the example ng pwede nyo makita or malaman pag gumagamit ng frequency band. In addition, okay, the Earth atmosphere can be divided into 5 concentric regions having boundaries that are not clearly defined. So the boundaries between the troposphere and the stratosphere is known as the tropopause, and this region varies in height above the Earth's surface. So from about 7.5 kilometers at the poles to 18 kilometers at the equator. Okay? So ulitin natin ah. This the What's the Earth? Same as this one. So 7.5 kilometers from the pole and then 18 kilometers from the equator. So an average value for the height of the tropopause is around 11 kilometers or 36,000 feet. About the same as the cruising height for the most international passenger aircraft. And the thermosphere and the upper parts of the mesosphere are often referred to as the ionosphere, and it is this region that has a major role to play in the long distance propagation of radio waves. So the lowest part of Earth's atmosphere is called troposphere, and it extends from the surface up to 10 kilometers or 6 miles. So the atmosphere above 10 kilometers is called the stratosphere, followed by the mesosphere. It is in the stratosphere that incoming solar radiation creates the ozone layer. So again, these are the Earth's atmosphere. So yan. And this is the radio wave propagation from the transmitter. Okay. From transmitter to the ionospheric path. Okay, dadaan siya doon. So, refracted and back to the receiving antenna. Um, maybe the transmitter signal, pwede siya sa tropospheric path, pwede siya magkaroon ng diffraction. From the satellite, kung nakikita nyo sa space wave, line of sight, or directly nakaka-receive kay antenna. Yan, these are the example of the radio waves propagation through the atmosphere. So these are the additional information about the ground waves or surface wave. The constituents of a ground wave, which discussed na rin naman. Ayan, the ionospheric waves or the sky wave. And these are the four effects can occur. Reflection occurs when a plane wave meets a plane object that is large relative to the wavelength of the signal. So kung mapapansin nyo from the aircraft, example, kung susundan nyo si VHF, ayan, kakaroon siya ng building reflection. Pwede din siyang direct ray, si VHF. Pwede din siyang ground reflection. Ayan. So in such cases, the wave is reflected back, minimal distortion, and without any change in velocity. So the effect is similar to the reflection of beam of the light when it arrives at a mirrored surface. So again, ulitin natin, si refraction occurs when a wave moves from one medium into another, in which it travels at a different speed. For example, when a moving from a more dense to a less dense medium, the wave is bent away from the normal. So diffraction occurs when a wave meets an edge. So kung makikita nyo, kakaroon ng diffraction. Here sa may mountain. Ayan. So which has a dimension that are large relative to the wavelength of the signal. In such cases, the wave is bent so it follows the profile of discontinuity. Diffraction occurs more readily at lower frequency, typically VHF and below. An example of diffraction is the bending experienced by VHF broadcast signal when they encounter a sharply defined mountain ranges or mountain ridge. Such signals can be received at some distance beyond the knife edge, even though they are well beyond the normal line of sight range. So sa scattering occurs when a wave encounter one or more objects in its path having a size that is a fraction of the wavelength of the signal. So wave encounters an obstruction of this typical, it will become fragment and re-radiated over a wide angle. So scattering occurs more readily at higher frequency like VHF and above, and regularly occurs in troposphere at UHF and EHF. So these are the additional information of various propagation effect, and hoping you understand the lesson. Thank you guys.